Stoichiometry is an essential part of chemistry that deals with measuring the amount of each chemical element in chemical compounds. This enables molecular formulas to be determined and allows us to write balanced chemical equations for chemical reactions. Once the stoichiometry of a chemical reaction is known, you can figure out how much product you will get from a certain amount of reactants and explain important ideas such as limiting reagents. In chemistry, we measure amount of a substance using moles. 1 mole of carbon has a mass of 12 grams. Moles are simply the units of measure we use to count the number of chemical entities in a sample. In other words, moles are a system of counting. In the same way that there are 12 eggs in 1 dozen, there are 6.022 times 10 to the 23 atoms of carbon in 1 mole. Using moles makes the numbers we deal with in chemistry much more usable. The concept of the mole was developed by Avogadro, and in recognition of this, 6.022 times 10 to the 23 is referred to as Avogadro's number, and is equal to the number of entities in 1 mole of substance. A mole is defined as the number of carbon-12 atoms in 12 grams of carbon-12. Measuring moles. 1 mole of carbon, a mixture of naturally occurring isotopes, has a mass of 12.01 grams. The number of atoms is 6.022 times 10 to the 23, or 1 mole of atoms. The molar mass of carbon, the average molar mass, is 12.01 grams per mole. This allows us to convert between mass and number of atoms, or moles of atoms. Molar mass converts between mass and moles. This means we can measure moles by weighing a sample. For example, if we have a sample of carbon with mass 33.92 grams, we can use the molar mass of 12.01 grams per mole to convert this into the number of moles of carbon. We must flip the molar mass around to have grams on the bottom and moles on the top, so that when we multiply, the grams cancel, and this leaves us with units of moles. When we calculate this out, we have 2.824 moles. This is the number of carbon atoms in 33.92 grams of carbon. If we want the actual number, we can multiply this by 6.022 times 10 to the 23 to get the number of atoms. There is some important terminology that is used when we're talking about moles of substance. Atomic mass, this is the average of the masses of the naturally occurring isotopes of an element, and is weighted according to their percentage abundance. The units used to measure atomic mass are atomic mass units. Molecular mass is the sum of the atomic masses of the atoms or ions in a molecule or formula unit. Essentially, we take the atomic mass of all the individual components of the molecule and sum these. Again, the units of measurement for molecular mass are atomic mass units. For both atomic mass and molecular mass, we often use the term atomic weight or molecular weight synonymously with these two terms. Molar mass, on the other hand, is the mass of 1 mole of chemical entities. This could be atoms, ions, molecules, or formula units. The units for molar mass are grams per mole. It's important to note a difference between the units here. For atomic mass and molecular mass, these are extensive properties. It depends how much you have. For example, 1 atom of carbon-12 has a mass of 12.000 atomic mass units, whereas 2 atoms of carbon-12 has a mass of 24.000 atomic mass units. This depends on the amount of carbon you have. For molar mass, 1 mole of carbon-12 has a mass of 12 grams per mole. 2 moles of carbon-12 also has a molar mass of 12 grams per mole. We can see that molar mass is an intensive property. Molar mass can be used for all chemical entities.